Good afternoon, folks.
I'm Ned Cake. I'll be moderating this session. You have joined the presentation the 10 rules of parcel mapping in the parcel fabric, brought to you by Frank Conkling of Panda Consulting. I'm going to turn over the reins to Frank here in just a second. This presentation is being recorded and we do have a hard stop time in 45 minutes. I will also be trying to unmute all of the attendees so that folks can weigh in if they'd like to. Not sure how that's going to work, but we're going to give it a try. So hold on here while I hand it over to Frank. Frank, you're now the presenter, and I am going to see if we can unmute all.
All right. And I am.
So the attendees are some of them are self-muted.
Okay. And I'm looking for a little bit more refinement as far as sharing my screen. Sorry. Change the presenter. Oh, I guess I'm just going to show my whole screen and that's it. So we'll be doing that. If that's the case, I might go and make this a little bit bigger. All right. So this is 10 rules of parcel mapping in the parcel fabric. I must tell you, we only have about 13 slides here, but having gone through this, it can go anywhere from 45 minutes to an hour, depends upon how deep we get into this. Just gonna look at introduction. I think most of you already know us. We're SHRUG business partners since 1998. We've actually been beta testers since then. We're surveyors in a couple states and such involved in it. So let's start with this and say the first rule. This is some of the things we have to do is that when you're parcel mapping, and this is whether you're in the parcel fabric or not, you should have not just polygons, but you should have corresponding lines. And the reason why you have corresponding lines is you want to go and you want to memorialize or document what the dimensions were, what the source information was on those individual parcels. Where did the information come from? How did it come in? And in the parcel fabric, what you have is that you have a set of layers. All right, and each of those layers has a polygon feature class and it has a line feature class. All right, and to show you here over in catalog, so let's look at our parcels. They have parcel polygons and parcel lines on here, so that a first rule, very simplistically, is you want to have more than just polygons. I can tell you, having gone to several clients, they just have polygons on here because maybe the regulations never called for lines on here. But it is important. You want to be able to memorialize this and see what's going on with it. The second rule is that all lines have to have a corner on them at the end of it. They have to end in a corner. Now you can, in the parcel fabric, there's some variation in there as far as what type of a corner it is, whether it's a constrained corner or what's commonly called a control point, whether it's a regular point or whether it's a retired point. And the reason why you have corners on here is so that if I go in here and select a corner, and I can go into a move on this, as I'm doing the move, I can see with these dashed lines that the corners connect everything else together. And the corners stand as the primary element that ensures that everything is connected to one another, the connectivity in there, and eventually they also will define contiguity. So whether or not this is contiguous with the other one, I can go and put it so it snaps on here and such. So you have to make sure that the endpoints of the lines, as far as the rules, that in fact you do have a corner on every single line on the end of each line. And again, you have inside the parcel fabric, you have different types of corners. You have fixed corners. These are control points, regular points, or retired retired points in here. And the way that these points are symbolized is, the easiest way to describe this or show this is to go in here and look at, in the parcel fabric, there is a field called is fixed. If this field has a value of yes in it, that means that actually in this data set, there is no fixed. There are no control points in here. So if it is fixed, it's a control point, and a control point can be thought of as a survey point. It's not a mapping point necessarily, but a survey point that has a known coordinate value on them. We can often think of these as being monuments on which we capture coordinate values, whether it be public land survey system monuments or whether it be subdivision monuments, maybe the permanent reference monuments, the PRMs inside that subdivision, or maybe the permanent control points, the PCPs, which are usually sort of points in the road right away. It's a control point. It's something that has a known coordinate value on there, which is used to maintain exactly where those corners are. One of the interesting aspects of the parcel fabric and the way it handles control points is that once a point is set up to be fixed, it doesn't move. You cannot go and move that point at all. It stays there wherever it is, so that even though you might be able to adjust other things around it, those control points, those fixed points, never move from their position. Distinct schemas, rule number 3. And this rule primarily is to show the difference between the ArcMap parcel fabric and the ArcGIS parcel fabric. But more importantly, it's to show that depending upon the type of polygon or the type of parcel that's being mapped, you would have different types of information that you would store about it. So for example, on this first one on the left, we have a tax parcel. And that tax parcel might have the municipality in which it resides, maybe a block and a right-of-way boundary type, and all these individual types of attributes. And these differ within organizations. You know, one county to the next organization, the next county, they have different types of attribution. Within Florida, we only really have one required field for that, and that is a parcel no. And that's one that the Department of Department of Revenue requires, that has the parcel number that's configured in a way so it can join up to a CAMA table extract. But other than that, each individual county is free to go and maintain and look at what type of information they want to store on it. Over on the right-hand side, the one that's selected right now, the table, this is actually the schema for the public land survey system sectional information. This is what's commonly called the second division on here. And this has everything from things like the principal meridian of that information. In Florida, it's the Tallahassee meridian, the township number, the direction, you know, whether it's 1 north, and the range number, range direction, and then any other types that they might have in here. But the third rule is that you can and you should have different schemas for each of these different types of polygons or parcels that you're going to be mapping inside the parcel fabric. It is highly recommended that you go and do this. The fourth rule talks about how you want to have some way to go and maintain the structure of the features that you're mapping within your parcel fabric. So you're going to use rules, and the types of rules that you're going to have are going to be topology rules and what's now called attribute rules. Now, a topology rule is interesting in that if you actually look at the rules that come with the parcel fabric out of the box, these rules are focused on internal, or they're focused on ensuring that the structure of a parcel is maintained. And the structure being, and let's look over here at the tax parcels, that the lines have to have endpoints on them. The lines cannot have dangles. They can't self-overlap, they can't self-intersect, and the lines have to be on the boundary of the polygon that they are attempting to memorialize. And then finally, the polygon has to have lines on them. Now note, it doesn't say anywhere that polygons can't overlap one another, that they can't have gaps between them. The topology rules that come with the parcel fabric are structural topology rules. They don't deal with how parcels or polygons interact with one another, only that they have to be internally, they have to have a structure which has a polygon, lines, and corners on the end of those lines. That's it. Everything else gets done not with topology, but with what are called attribute rules. Now, an attribute rule, there's actually 3 different types of attribute rules in here. There's the first type, which is a calculation attribute rule. That calculation attribute rule allows you to go and set a trigger so that every time one thing happens, something else happens. And in this case, this is highlighting here, it says you're going to calculate the acreage. And if we look over here, it's using it's correcting the calculated area field in here, and it's going to go and calculate the value for that. And it uses an arcade structure. That arcade structure is referencing the polygon that's being created. That's this $ feature. That's that object that's being worked on. And it's going to pull out of there the area property, which is outside here. It says calculate or return the area of this feature that's being worked on right now, but return the value in acres. One of the good things about Arcade and about the features that we're working on right now, it's this object-oriented model, which says we can pull this information out, this property out, and we can return it in different formats. We can return it in acres, or we can return it in square footage. We could return it in hectares or whatever we want to do. But it goes and pulls it out and returns it to us and says, take that value and calculate it into the calculated area field. And then we have triggers. Well, when are we going to do this? In this case, the triggers are set so that anytime we insert a new feature, anytime we create a parcel, go ahead and run this rule. And also, anytime we update this parcel, so anytime we change the location of it or change the location of one of the corners on it, or anytime we clip it or split it, go ahead and recalculate these on here. So rule number 4 deals with how and when we go and apply rules to the information that we are actually maintaining. One of the real benefits of this is that because of topology, meaning we make sure that we have a complete feature, a parcel, polygon, lines, and corners, and because of the attribute rules, we can make sure that the data that is put in place and that is created, make sure that it is correct and make sure that it fits into what we have defined as our structure. Now, right now, all we've done is we've gone over the calculate. There's also a constraint where we can put a constraint rule in here, and we can define that rule to say something such as constrain it so that I can't build a polygon that's smaller than 100 square feet. So it would eliminate the ability to go and create sliver polygons on here. So you can put a constraint in here, and what a constraint rule does is it goes and checks to make sure that that constraint is passed. And if it doesn't, it returns an error to you saying, this parcel is too small. You can't go and build that. Or we can build a constraint rule in here that says, make sure that if we're building a lot, within a subdivision, make sure that that is inside of a subdivision. So it will go and validate that it's being built on top of a subdivision polygon, so that it goes and makes sure that you can't be building things where they shouldn't be. You building a lot outside of a subdivision, or building a parcel in the middle of the water. Those are the types of constraints that you do. And a constraint rule doesn't necessarily do a calculation, but it makes sure that that rule is complied with. And if it's not complied with, it returns an error to you. All right. And then finally, there's a third type of rule, and that's a validation rule. The validation rule stops you also from doing that. So I can say that if I'm building a meets and bounds parcel in which I go and I type out the various courses I can say, make sure that this meets and bounds description that I have closes to within a certain parameter, that I can't have a misclosure more than 2 feet or 3 feet or whatever, or my misclosure ratio isn't too big. Or make sure that I validate that the information that I store for the length of a line is not too far of a variance from the actual mapped length of the line. So I can't put 100 feet on a line that's 500 feet long. So it's a way to go and validate that, in fact, it meets these rules. So this rule number 4, this topology and attribute rules, is really very, very important. And it takes parcel mapping from just a sort of like chiseling a piece of stone in the Stone Age into really, testable level. This is the way this should work. Let the software become smarter. Let our data model become smarter as far as what we're doing and how we go and integrate it. Let's create really good data models. Let's create our parcels so they fit within the rules of how they should work. The downside to this: the introduction of attribute rules goes, by the way, the attribute rules are stored in the geodatabase. They are not stored in some external table like the old attribute assistant was with ArcMap. And once you go and build attribute rules in a geodatabase, you can no longer read it by old technology. So this is ArcGIS Pro. If you put attribute rules in here, ArcMap cannot read what that is. It doesn't know what those things are. So you can no longer use that database for it. Same way with, you can't do it with ArcView 3 anymore. So you just want to recognize that this is one of the newer technologies, and this is very, very important. And you're going to see Esri really enforcing this more and more. This is where all the design is going to come, not in what is the schema or what's the number of layers you have, but in here, how do you make your data more intelligent in what it's doing? That rule number 4 is, as we say in South Florida, muy importante. It's very, very important. We're going to see a lot of work going on here. I can tell you the next release of software, there's already some rules being put in place here. Things like, you can't go and build a parcel if you don't put a parcel identifier on it. Simple little things like that, that I can tell you, in going around and looking at other counties' data, there's a lot of stuff out there. We see a lot of areas where we could or should go and look at enforcing these rules a little bit more.
Hey, Frank.
Yes.
Before you go on to the next rule, I just want to let the attendees know that you are only muted by yourself. If you want to talk to Frank or ask your question, just unmute your microphone and give it a try.
Thank you. Thank you. I would love, don't save questions for the end, because we'll have forgotten what your question was. Ask them now. Just interrupt me. I have no problem being interrupted, and we want to address the concerns that you have immediately or any questions you have. All right,
Unmute yourself by just clicking the microphone on the control panel.
thank you. Thank you, Ned. Rule number 5. Rule number 5 has to do with the way in which the parcel fabric keeps track of everything that's going on. And the way they do this is they have a layer called a record layer. This record layer is a polygon record layer. And when that record is active, and we can see it right here, this is an active record here. When that record is active, it tells the software to go and tag everything that's done with a reference over to this record. So in this case, it's tagging the created by record here with the global ID of that record polygon. So with that, we can go and make sure that, let's go out of here, let's clear this, let's create a record here. All right, let's go and make sure they're there. Let's create a record here. All right, and this record, basically, I'm just going to go and create it. Doesn't matter what I call it right now. It will go and create this record, and it's now active. Now, when I'm in here, and I'm going to open up my attribute table so you can watch as this happens. When I go in here and I create a parcel line, as I create, let's go back here. As I create this parcel line is actually going to be tagged with the global ID of this record, so that when I create another line, if you note here and watch here, it's going to be exactly that same number. All right, so I created another line in here and another line in here, and now another line in here. So all of those lines that I just created, I created them, and it is watching what I'm doing. It is tagging what I'm doing. So the point where I can actually go in here and say, well, show me everything that's associated with this record. So it's associating things with the record. And as it associates things with a record, it now allows me to go in and sort of group those together and act on them as one. So I can say, take all of my active lines, all the grouped lines that I have with this record, and check and see if in fact they form a closed polygon. And I did that, and it actually creates this little thing down here called a seed. And it says, yes, you have a closed polygon on there. And I can say, well, let's build that polygon out. Let's expand it until it reaches the limits of my lines. And when I do that, look at this, it tagged that polygon with exactly the same global ID, the global ID of this record. This is how it tracks what happens with this. And that includes things that it creates and things that it deletes, so that a record becomes the grouping mechanism, the tagging mechanism, so it can keep track of things. And once you've put that into your database, and once you start tracking things with it, you then begin to be able to start doing things like showing me the lineage. Where did this parcel come from? So we can go back through this records lineage to find out, well, what it looked like before this, because you're tracking not just current information, but also historic. Over here, we can see that we have historic lines and historic parcels. So we can see when was something changed and what record caused that to be changed on there. The record is a way to go and tag things so that you can retrieve them in the future. The record also, once it's active, turns on all of your parcel editing functions as far as the parcel fabric. quality-driven workflows. So one exception to Rule 4 is that when you're cleaning up your data, you really don't want to track the things that you are just cleaning up. So if in fact I've got some data that's in the wrong place and I want to go and move this, or I want to change the way this is built, I can go and turn off my active record. And if you look right in here, this is the construction tools for the parcel fabric. The copy lines to, the create seeds, the builds. And if my heads up display here for my records, if I open it up, those become active. When I close them down, they are no longer active. So anything I do now, such as creating more lines, I could create lines and do all sorts of things in here. All of these, none of them get tracked. None of them get tracked. So they are not part of my record. And I can use that to clean things up, to move things around, to fix the data that I have that's in the wrong place, not quite the way it should be. And we all make mistakes. We're all trying to do the best that we can as we go along, but we know that the person who's no longer working for our office, they really didn't do a great job of mapping this, but we're trying to fix their data. Well, we don't need to have a record of what we had to fix. So we can turn off the record. We can do what's called quality-driven workflows, which means clean things up, or record-driven workflows, which means track what we're doing and maintain that because we need that for everything. So I just created 3 lines here. I can go in here and say, show me everything that's associated with my record. There it is. Those 3 lines are not associated with a record. I can go back here later and take these lines and I can say, go ahead and assign them to this record. So maybe I forgot initially. I can say assign them and then see if there's a seed, build them and such. So the parcel fabric tools, the copy lines to, the builds, the create seeds and the build, those are really the only tools that are specific to the parcel fabric. All the other tools, if you are working with a fabric, they're fabric aware and they change slightly the way they work, but those are the only 3 that are only parcel fabric in this release. Next release is going to be a whole lot more, but they go and they work against records. And when you don't want to track the information, you can make your record inactive and it then becomes quality. You're fixing things. You're doing quality cleanup on your data. All right. So what happens if somebody wants to go and migrate from the ArcMap parcel fabric? There is an upgrade script that uses the ArcMap parcel fabric plans table to create records. Because remember, records are the key to everything. The records are the feature that goes and shows you how things are related to one another, where they came from. So it uses your plan table to come over and bring that in, but there's a whole bunch of caveats on here. If you're not in a parcel fabric right now, if you're not in the ArcMap parcel fabric, you don't have to worry about this. But if you are in the parcel fabric, there is this upgrade script that allows you to go and upgrade it. Just be aware that there's a lot of caveats there, a lot of things you need to know about it. It's not necessarily just one button on here. Densified curves. This is one of those things where this is the skeleton in our closet. The fact that in most of our data, we have vertices that have been introduced, and they can get introduced in a couple different ways. Those vertices are introduced by the fact that there are several types of data structures that don't understand what a true geometric curve is. All right, let's see if I can find some in this data structure here. And by not understanding what a true curve is, this is one here. Let's see if I can find something that's got more of it in there. I've got to find the points in here. This one here is a little bit better. All right. So this was cleaned up, but not all the way. So a shapefile has no way of storing a true curve. What it does is it approximates a curve with a lot of short little lines, straight lines in here. It's one of the reasons why one of the things I tell people is that when someone asks you for a shapefile and you've got data that has curves in it, don't give them a shapefile unless you don't like them. If you don't like them, go ahead and give it to them. Don't care about it. There's the data. That's what you asked for. Don't worry about it. But if you care about the quality of the data, you never store a curve in a shapefile. It also, we can have densified curves in there by having historic information that predated sort of ArcView 9, I think it was, because at that time, Esri didn't have real curves in there. It wasn't until about 9 that I actually started storing true curves on here. So the question is, how can you go and remove these from here? Matter of fact, here, I think I've got somewhere in here. I'm looking at this as some old data. Nope, sorry. So how do you go and clean this up on here? Sorry about that. I've left that area. Here's one here. So this is what densified curves look like. So I'm going to show you that what I'm going to do is I'm going to go in here and I'm going to turn off my topology right now. I'm going to use a tool. I'm going to use a tool called Align Features. And what this Align Features tool is going to do, I'm going to put a tolerance in here and say that go and look at all vertices that are within 2 feet of this curve that I just drew. And I just used a 2-point curve. And I said, take all these vertices and replace that geometry, realign and replace that geometry with these new curves. When I finish with that, it's going to take the geometry on all the layers that are turned on right now, everything from the tax parcels to the lots to subdivisions to whatever I have turned on and editable. It corrected the geometry all the way through there. So now I can go in here and say, well, let's look at our old data that we have and take those lines and those points that it corrected, and I'll make sure that I only have points and lines. So it corrected that line in here. And I'm going to say delete them. And then I'm going to use my Parcel Fabric tool and say rebuild what's in here to go and re-put those lines on here and re-import everything that I need on here to replace that and have valid lines and corners and everything else in here. So I've eliminated those old densified curve in here. All right, that's correcting densified curves. And again, you use the align features, you delete the points, turn back on topology and build the extent in here. this is one of those things that most people aren't aware of. And the reason why you aren't aware of it is that in ArcMap, you never see your vertices on here. The only way to do that is be in an edit function and hit the V key, and it shows you vertices that are within about 500 pixels of where you're at. But other than that, you don't see it. And it can be caused by older shape structures, having ones that don't support geometry or don't support curves, or by topology. Topology works by going, and the first thing it does is anytime two features intersect one another, it goes and inserts vertices where they intersect, so it cracks them. And then it clusters them together, and then it runs against the rules in here. But we have vertices everywhere in our data. Sometimes it's all right and acceptable, but other times, like with densified curves, it really isn't. It just shows us where, in fact, we have problems with our data. Ground to grid. One of the interesting things about this is that almost all of our data, from parcel data standpoint, is projected onto some sort of projection grid. However, oftentimes we'll get information in that is on ground measurements or ground bearings. So, for example, if I go in here and I'm producing a drawing and my original meets and bounds description says that this line, let's go and actually see what this line actually is on here. Let's go and tell it to go and show us the bearing on this line. All right, so this says that this is south 1632.33 east or north 1632.33 west. Well, let's say we have a survey that comes in and it says, oh, this is actually north 10 degrees west instead. Traditionally, we would go and build this and then have to go and rotate it and such. Well, instead, what we can do is we can actually go in here and say, let's start a line. And this is our point of beginning. But let's go in first and turn on our ground to grid and say, yeah, let's go ahead and define our ground to grid. And let's enter and say that now the bearing that we put in here, it's going to say it's north 10 degrees west. All right. And we're going to go and say, redefine it. So for this survey that we're inputting, that line there is now north 10 degrees west. So now when we put our survey in, and this is north 10 degrees west, all right, for a distance of 100 feet, you'll see it's actually going and it is parallel to that existing one. And what I can do is I can now go and say, well, let's go 90 degrees to that other one, and for 100 feet, and then another 90 degrees there, and then another 90 degrees back to close out. And it closes everything, but the ground to grid correction, the basis of bearing correction, allowed us to take and document the information that was stored on our survey or on our legal description or on our plat, and have it automatically rotate so that it's in sync with what we have in our existing mapping. So we can go ahead and do that by utilizing this ground to grid function on there. And by the way, that stays active. That stays active while I'm using any one of those tools that goes and utilizes inputting or creating lines and such. And we see it's down here. So as long as that box is blue, it's going to use that grid. And if I uncheck that and that box is no longer blue, it's not going to use that grid anymore. It's going to use its standard, whatever it is relative to the current grid basis that I'm mapping in. So that ground to grid conversion allows us to go and apply an automatic rotation and a scaling if we wanted to. So if we really wanted to get down to doing geodetic surveying, we could actually tell it what the scale factor was, the difference between the ground distance and the grid distance on here also, by going and utilizing this ground to grid here. All right. So these tools that are in the ArcGIS Parcel Fabric, the interesting thing that's happened is that in using them, we recognize that the best way to go and build, the best practice now, was to go back to old school mapping techniques. And when I say old school, I mean ink on Mylar. I mean laying it out with a compass. I mean the techniques that we learned when we first started mapping, things such as what FACM, what the Florida Association of Cadastral Mappers teaches people. This is old school mapping. So when you want to go and build it, you build it from, for example, the outside in. If you're building a subdivision, you build the outside of the subdivision. You go around the outside of the subdivision boundary, you build that, and then you put it in place and you make sure it closes. Then once you've built that subdivision, then you go and you build the spline road that goes between it. You build the road center line. And then from that, you go and do parallels from that road center line and build the rights of way. And then you split them up into blocks. So this is old school. This differs greatly from what the ArcMap parcel fabric did. That used a different technique. Interestingly, that technique was applied from New Zealand because that's where that ArcMap parcel fabric originally came from. The ArcGIS parcel fabric goes back to using the old school FACM mapping techniques. You build it from the outside, you then isolate any error to just within the confines of that subdivision. You build that out, you prorate inside the subdivision. Once you've built the subdivision, the road center line, the roads, the blocks, the lots, you then copy them into tax parcels and build it that way. This is old school techniques. So 10 new rules for parcel mapping. They are roads and polygons, or lines and polygons. These are, everything has to have a corner on it. Distinct schemas. Use rules, topology and attribute rules. You have to have records. Quality-driven workflows, migrating from the ArcMap parcel fabric, correcting densified curves and cleaning up your data, using ground to grid and old school techniques. That's it. Any questions? Ed, anything to?
Okay, folks, so if you're not comfortable talking out loud on your mic or you're having technical difficulties, go ahead and type a question in the question box in the control panel. And if you have any. Otherwise, if you want to just speak out loud, you can click on the microphone and unmute yourself. You are not muted by us.
Let me do one more thing while everybody's trying to get that through. Let me just go and mention to you that we actually conduct free workshops, and Ned's actually helped us quite a bit on this. We do a free workshop the first Thursday of every month. It is ArcGIS Pro. You want some free ArcGIS Pro training? These workshops are available to you. The third Thursday, which is today, it's a free 90-minute workshop on the ArcGIS parcel fabric. The fourth Thursday is in fact what we call the deep dive, in which we look at topics and really explore them. And again, I'm very thankful for Ned. He's helped us with deep dives that go into arcade and story maps. And Ned, I don't know what else, you've helped us on so many of them, but it's a whole series of them. So if you go out to our website, you can see the individual workshops that we've had, and we've been doing since since COVID hit. And you can go and you get a short snippet of what we talked about in here. And then you can also register. When you register or sign up, all it asks for is your email, your address, and where you work. That's it. We do not use this for marketing. This is purely for these workshops because we had to go and avoid Zoom bombing. So please, if you want free training, if you want to just learn a little bit more about something, the difference is these are very interactive workshops. There is no set, we don't have slides. It's like, what do you want to talk about today? And we go into it and ask questions and suggestions and make sure that you learn this information, all right? Thank you all. I've really enjoyed giving you this presentation, and hopefully you get something out of it. And
No
applaud
questions
it.
so far.
No, I'm very thankful for SHRUG. I miss coming up to Tallahassee.
We miss you too.
One of our favorite trips every year. So hopefully we could all get over this thing soon and move on from it. We'll
Yes,
see.
please.
Yeah, I hear it. I hear you. All right, Ned, I'll send it back to you.
All right, thanks everybody. I believe we have another session coming up here shortly, so we'll go ahead and end this session now. All of our sessions are recorded and you will be able to watch them later. We'll send an email out to all the participants on how to connect to the videos later. Thank you very much, Frank. See you soon.
Thank you, Ned. Yep.